Hello everyone and welcome back to this next lecture. In the previous few lectures, we had downloaded and installed CodeComposer Studio. We had downloaded and installed controlSUITE, and I had also shown you all the files which are installed, or rather which are available once you install controlSUITE. So in this lecture, we are going to get started with this entire setup that we have built over the past few lectures, and we are going to use it, or rather get to know it with our microcontroller kit. So for this lecture, it's very important that you connect up your microcontroller kit to your computer, open up CodeComposer Studio, which is what I have done right now, and make sure that your microcontroller kit is connected and active. And the way to ensure that is by ensuring that the switch is in the USB position and you are getting glowing LEDs on your microcontroller kit. So I hope your microcontroller kit is in exactly the same state mine is, that is, you have those few glowing LEDs that I have shown, and it's important that you should see those LEDs, because otherwise it probably means that your kit is either not connected properly or is not powered up properly, or maybe the control card is not inserted correctly. Alright, so make sure that you are in pretty much the same state as I am in. So now that we have this, I'm going to show you how we can get started. Now here, of course, as I said, this getting started page in CodeComposer Studio is quite useful. You can do lots of these things, but I'm going to close this down and show you how we can actually get started on our own. Okay, so the first thing I'm going to do, now it's important to understand that we have to do a few other things before we can actually start running programs. There are a couple of things which we can do, and it's best that we do it incrementally rather than me doing it just at one shot and you following along. So as I already said, let's go back to our examples, and here in our controlSUITE directory in device support, okay, let me just go back all the way. Okay, so there is CCS, there is controlSUITE which we have installed. If you have installed controlSUITE in your C program, in your C drive or anywhere else, go ahead and open it. Wherever you've installed it, go to device support, go to F28069, because we are programming with the TMS320 F28069 microcontroller chip. In this, you will see the latest version is 151 as of the time of making this video. If you are seeing another version more advanced than this, please do click on that as well. And here, let's go over to examples. Now these are all the examples which are available with your microcontroller kit. Now this can be run directly on your microcontroller kit because these are working projects, except that, as I already said, these are projects which are configured for CodeComposer Studio version 5. So it's pretty old. So we will have to make some changes, and I'll show you what those changes are. But let's go through these. A lot of these are fairly advanced. I'm not going to go through them. Like ADC is a very advanced concept. We will not be using the controller accelerator, CPU timer. There are several others. Now there are a couple which I am very, very fond of, because they are the easiest for you to check out that your kit is working. So the best one which I am fond of, let me just actually go to large icon view so that you know. Look for the folder timer LED, timed LED blink. The reason why this is most useful is because you will see an LED flashing on your kit, right? So with respect to the video clip which was there before, which showed the microcontroller with those two green LEDs, we will now see a flashing LED. So it's the best way to visually check that your microcontroller kit is working and active. Okay, so here if you look, there are a lot of these things, right? Let me go through this bit by bit. So let me go over again here, and in this CodeComposer Studio, go to File, or rather go to Project, and pick out Import CCS Projects, right? Later I will create a new project when we start actually building projects from scratch, but for now we are only checking with our microcontroller kit and our Code Composer Studio environment is all working correctly. So go to import CCS projects, because this way you can import an existing project, which is what we are going to do from the example projects. So let's click on this. Now you have to choose a search directory. So what we're going to do, I'm going to go and browse to that. So this is the CCS directory which automatically comes because it picks out the home directory. I'm going to go to device support. I'm going to go to F2806X because this is the microcontroller family which we are using. I'm going to go to version 151 because that is the latest version. And I'm going to go to examples, right? So this is the directory which we are looking for. So let's select it. This will automatically list out all the examples which are available in this directory because these are all projects. So as I said, go all the way down and look for timed LED blink. So apparently it is called LED blink. I was looking for the wrong example file. So again, this is my mistake. So you see, this is how it is called. It is called LED blink. And I was actually looking for that. I was looking for timed LED blink. So you see, this is the directory name and this is the example file. So let's go and click on it and finish. You don't want to select all. We just want one of these. So that's it. So click on finish. And this is our project. So once you click on this, you will see automatically, you'll see this page which appears, right? So again, there are several things. You see, there is a very small little cross, which means there are problems, right? There are already problems. So you see, one of the reasons why there are problems is because this has been prepared with Code Composer version 5. We are at version 12. There's a huge difference. So these are all the files which are there in this project, right? Now you might wonder, do we need all this? And the question is, yes, we do. And this is why I wanted to show you all these files. These are source files which contain those helper functions, right? Again, let's not go into the details here. We are only trying to get it to work, right? So here you can go, you see here, you can actually open. Let me open the example 208X C program, just so that at least we see what it is we are looking at, what we are trying to compile. And this is what we get. So there are already, you see, a number of errors. You see, the first thing is here. This was created with an old version of the compiler, which is not currently installed. So it's straight away screaming that you are using a much newer version of the compiler, and this was compiled with a much older version. Now you can read through this file. This file, as I said, we won't go through it around because we're just trying to get it to run, and there are a few steps needed to get it to run. But you can see what it does. It configures one of the GPIO pins along with a timer to be able to flash the LED. Now specifically the GPIO 34 pin, okay, GPIO 34 pin is connected to one of the LEDs on your control card, right? This is done internally. You don't have to do anything. This is done internally for testing purposes. So therefore, if you configure it as an output pin and you toggle the pin in a timer, the LED will flash on your kit. Alright. Now, again, we are not going to go into the details of the program because we still have a lot of theory to cover. What I'm trying to do is to show you some of the things we need to do. So the first thing we should always do when we get a project is right click on the project. Okay, right click. If you right click on the project, you will see several options, right? And I will go through these options as we start building projects. But for now, go into properties. Right. So these are the properties of the project. Right. Now you see here there are several. This is the general, the configuration. The most important thing is your configuration. You need to be able to manage your configuration and you need to be able to say what it is. So you have a debug configuration, which is good enough. if later on, as you become more advanced, you can have different configurations, and accordingly you can adjust what it is you're trying to do. For example, you can have it in debug mode, you can have it in burn mode, you can have several of them. I won't talk about that right now. Most important is we need the family, right? Because right now it doesn't have the exact family. So what I would say, go over to 20866 Piccolo and pick out the experimenter kit. This is what I have, which we are going to use in this project, or this course rather. And this is there, I would say this is one of the first few lectures. If you go, these are the requirements for following this course. We need the experimenter kit, which is the Piccolo kit, and this Piccolo kit has a control card which has the F28069 microcontroller chip. So choose it. Now the connection. Now the connection is, you have several. Now as I have already said, you can install any of these Blackhawk, and if you have a Blackhawk emulator, you can use it. These are very advanced emulators which give you some very nice functionalities. So if you have a Blackhawk emulator, by all means go ahead and use it. But what we will be using, if you have not bought any of these and you have only what is there, you have the kit and the USB cable, even then you have an onboard emulator, USB debug probe, which is available with just the kit and the cable. Alright, you don't need an additional emulator. If you have the Blackhawk emulator, you can use it. But I am assuming that you don't have anything, because after all, like I said, all we need to follow this course is the kit, the cable, a computer, and a few other very simple basic electronic components. So what we will use is this one, the Texas Instrument XDS 100V3 USB debug port. You can use some of the others as well, right? This is what is there in your kit, right? So let me choose this, and you can verify it. Always click on the verify to make sure that you are able to connect successfully to your kit using from your host computer. Because if you cannot connect to your kit, then nothing will work subsequently, right? So let's wait for this. Okay, so you see here, it says there is an error. So in that case, the best thing to do is to go ahead and use another one. So let's say I will use the 100V1 instead. And this is always possible because, like I said, the kits might change. It is always possible you might have something different, whereas I might have something different. So by all means, check out each one of them, 100V1, 100V2 and 100V3. So let me try it again. And you see, everything is perfect now. Let's go back here and go through this. It is running the command where it tries to connect to the kit. So the host computer is trying to connect to the kit. It is then trying to run all these things. You see, it is checking the library, it is checking the kit, it is checking what is the firmware on the kit. It is checking that it is all these. There are a few things which apparently it cannot do. It cannot monitor the value of the EMU pin. Don't worry about the details. We'll talk about the details later. There is no hardware for programming the JTAG clock frequency. There is no, again, we'll talk about that later, about programming the JTAG clock frequency. The JTAG IR instruction has succeeded. That means JTAG DR path is succeeded. And let's keep going. So these are several tests which it is doing, and you see all of them have passed, skipped 0, failed 0, right? So all the values were scanned correctly. JTAG IR integrity scan test connected. What does this mean? JTAG is what is used to communicate with your kit. This is how your host computer connects with your kit. And when you see this message that it has succeeded, it means that you have successfully being able to communicate to your kit through your host computer. So you're okay. And all these are also done. So your connection to your computer is now set, and therefore henceforth I will use 100v1. But the reason I wanted to show you this is that there are three possibilities which are there: 100v1, 100v2, 100v3. If in doubt, then if something doesn't work, of course, check out the documentation. When you get your microcontroller kit, inside the package there will be a document. It's more like a glossy paper, but that glossy paper will show you some details of what is available and what is not, right? And in one part it does show you which version of the USB debug board can be used with the kit. But in any case, make sure that if one of them doesn't work, try the other and click on this verify to make sure that your connection is successful. So now let's come over here. So you see we are now using a new version of the compiler. You see it is much later, and that X is gone, because now what it means is it is saying we have already upgraded to the latest version of your compiler. Now the rambling file is this. Again, details later. This is all a little too complicated, so I don't want to go into details too much. And finally there is an automatic. Do not play with these files. Choose the automatic. Let it automatically choose what it needs to for the runtime support library. These are advanced concepts. We won't talk about that much in this course. The main purpose is to get a normal power electronics engineer to be using Texas Instruments products. Okay, so with this I will close this dialog. We are still not dead done. There are still a few things left, but I just wanted you to get used to it, because there are a few other options which I will go through very soon once we start getting errors. So like I said, few more steps are there. We are not ready to run yet, but I will show you that bit by bit. So apply and close. So we are ready. So the first thing we are going to do now that we are here is, let me go right click again. Always right click, and you will get these options. So we will clean the project, which means we will delete any of the pre-compiled files which are already there. So cleaning is something we should always do before we run another version of build. It's always clean and build. So usually I would have seen something. Okay, let me just run the build project. Now that we have cleaned the project, you can build it. Again, there will be some errors and we will go through them bit by bit. So you see, this is the very first error that you're getting. Product XDAIS version 0.0 is not currently installed and no compatible version is available. Please install this product or a compatible version. Now, the reason why I wanted to show you is this is a problem that you'll find whenever you run any project in your examples directory, any project. And the reason is that in the older versions of Code Composer Studio, there was the need for this package XDAIS as this is something more of a hardware layer. In the later versions of Code Composer Studio, this is no longer necessary. So how do we get rid of this? We again right click on the project, go to properties, and we go to products, right? I showed you the project, now we go to products, and you see there is this XDAIS, right? XDAIS is automatically enabled in the project settings, but we don't need it anymore. This is no longer necessary, so we can remove it. Click on the remove here and we can get rid of it. So click on apply and close, and again we come over here, again repeat the same process, again clean project, and you see the clean is done. Now that the clean is done, go back and click on build. Now it's important to note, again there will be errors. That's okay. I want to show you the errors bit by bit. So we click on build, it comes all the way down, and there are some errors. You can see the errors already coming up. Okay, so here are your errors. So there are some options which are not there. Okay, now these are a little complicated, right? And I'm going to show you how to get rid of them. All we have to do is come over here, click on project settings, right? Now, up till now, I showed you only the basic settings. That is the basic product and the basic product. Now I'm going to show you the compiler options. Okay, so just once, let me just pull this aside and see. This is --c debug ASM data is no longer supported. So for that, let me go over to the build options. Now the build options are what makes the compiler, right? This is the compiler. This is how it compiles your C programs and converts them into object-oriented program, or not actually object-oriented program, assembly language code, which is finally written to your microcontroller. The compiler does this, right? So let me go through it bit by bit. So a lot of these things you don't really need to know, but I'm going to just show you bit by bit. So you see here, there is this error already showing up, right? The error was showing up in any of these options. It was not showing up here. It's showing up here. C debug ASM data is no longer supported, right? So let's go. It means somewhere in this option, which means in all these sub options in C2000 compiler, this error is somewhere there. So let me go one by one and search for it. Now, do you see --c debug ASM data anywhere here? The answer no. Keep going. In the optimization, we don't see it here either, anywhere, right? These are some other things. Include options. I don't see it here either, so no problem. You will see an error somewhere here, right? Keep going. Performance, I don't see it here either. Predefined symbols, not here either. Let's go to advanced options. In advanced options, you can expand further. Advanced debug options, language options, don't see it here. Preparser options, don't see it here. Diagnostic options, do not see it here. Runtime model options, C debug. Look, unfortunately this is the only way to do it, because this is a flag set somewhere, and the only way to know is by going through each and everything and finding out where that flag is set and unsetting it. Okay, keep going. Not here. Assembler options, and here we have. So you see, keep going and you will see this little red flag here. This red flag indicates that this is the offensive option, right? You see, it is saying generate ASM debug directive --c debug ASM _ data, right? This flag is set, and because this flag is set, this compiler option appears, but this compiler option is no longer supported in the latest version, and therefore our build is failing. So what we're going to do, uncheck it and keep going. Go through all of them and see if it is set anywhere else as well. You will immediately see the error. The error has disappeared, which is a good sign, because it means that unchecking that box solves the error. But just go through once and make sure that there is no other little red flag anywhere else. I don't see a red flag, and nor do I see one here, nor here, and nor here, and nor here. So I will apply and close. Again, this is an advanced concept, but the way it works is that in compiling, whenever you compile a C program, there are several files and there are several options which you can use, and C debug ASM data is one of those options which allows the compiler to generate some additional object files. We don't use those object files anymore. That's why there is a conflict. So let me go up here. Again, repeat the process. Clean project. So you see everything should be okay. Build finish, finish clean. And let me go right click again and build the project. I still don't expect it to work because there is one more error which is still there, and I will show you what that is. Okay, let me look at what it is. And quite interestingly, it has not given another error. So this is very interesting, because the reason why I said there will be one more error is because I used version 11 of Code Composer Studio several months back, and in that version of Code Composer Studio I was getting another error, but now that error is gone. So this shows how using the latest version of Code Composer Studio is extremely important in order to ensure that your systems are always up to date. So with this, we now have, so you see the latest one here. It's very important that you read this latest part. All this is just showing what it is creating. You can go through this, it's fairly complicated. But what is most important is, you see, finished building target example 208x LED blink out. So this first part is the name of the project and is also the name of this file. It has created a .out file for this particular project, which means all the contents of this project have now been converted into this one file. This one file which will be downloaded onto your microcontroller. So in order to do that, there are several ways. I go to Run and I will go to Debug. When you go to Run and Debug, now it will launch the debugger, which will connect to your microcontroller kit, and you can run your code interactively. So you see, this may happen. It will then do all this. You see, something is still happening here. We have to wait. And you'll see, when you get this position, you see here, you'll see a lot of buttons appearing. This is when your debugger is ready. Right? You are now ready to run your program. So to run your program, you click on this, which is the resume button. There is a stop button, there is a pause button, suspend button. There are several other buttons. Again, we may go through some of them later, but I won't go into these so much in detail, because the main objective behind this course is to understand how to program microcontrollers and not really to use the IDE. But most importantly for us, we need this resume button. If you click on the resume button, your program is now running. And if you check on the next video clip, you will see what I mean by running. So what is important is, you might have seen, make sure that you are getting a red LED flashing on your microcontroller kit. Reference the video clip which is there just before this segment. In that, I have posted a video clip of my own microcontroller kit where the very first LED on the right hand side of the green LED is now flashing. It might happen that in your microcontroller kit, another LED might be flashing with another color. It is always possible, because they do make these small changes. However, you should see an LED flashing on your microcontroller kit. If that is the case, then you have successfully set up your microcontroller kit, you have successfully set up your Code Composer Studio, and we have run our first project. Of course, this is a very minor project. All we are doing is flashing an LED. But then again, what's important? First step is always the most important. So this is reason to celebrate. You can always close down the debugger in this manner, and it will go back to the default page. So what is most important here is for everyone to remember, whenever you have any project, whenever you import any project from the example directory, always go to properties. First thing you must do, go to properties, go to general. You must choose your experimenter kit, right? Just a recap, you must choose, I think if you choose experimenter kit, it automatically has chosen your variant core. But if you want, you can also choose the variant core here in 2068X. But I think this experimenter kit implies that that is the F2806X. The second step, you must choose your connection. As I said, there are several options. If you have a Blackhawk emulator, by all means go ahead and use it because those are advanced and they have several very nice functionalities. The inbuilt ones are the Texas instruments. It is one of these. Usually it is either 100 XDS 100 version 1, XDS 100 version 2 or XDS 100 version 3. Which of these are there on your kit? The best way to find out is to check out that glossy paper you get when you buy your kit. That is, when you buy your kit, you open that cardboard box, you will see a glossy paper along with the CD, and that glossy paper contains that information. If you lose the glossy paper, then in that case, the best way is to choose one of these and to make sure, for example, I'll just choose one of these and click on verify. Most important, the end result to verify should be that your JTAG connection has been successfully completed, right? Then make sure that the compiler version you're choosing, you can choose it automatically results to the latest, because once you choose Code Composer Studio, it comes with its own C compiler, right? The rest of them, it's not advisable to touch right now. I will show you these differences later. But as I said, there is this annoying little bug which was there before, which is that --cdebug ASM data flag is no longer supported, and for that you have to unfortunately go through all these options and find out exactly where that flag has been set and uncheck that box, right? So just make sure you go through this video. You might have to watch this video once or twice. You might, because remember there are 3 steps, right? The very first one is removing XDAIS, right? Because this is a legacy product which is no longer needed. Then make sure that you remove that advanced option somewhere else, right? And finally, you can, of course, run your program once that is done, right? To make sure your program's running, all you have to do is click on clean and build. Clean and build. That's it. Every time you make a change in your project, always clean it and build it. If there are no errors at the result of your building, that means your code has been successfully compiled. And once your code has been successfully compiled, it's important to remember, look for this last line. And I'm waiting for that line to appear. This is the most important line. Finished building target with this .out file. This .out file combines all the files in this project and everything that you have done, and it combines it into one .out file, because this .out file will then be converted into a assembly language file which will be downloaded onto your microcontroller kit. And in order to do that, you just have to go to run, go to debug, and this will open the debug window, which if you have been able to successfully connect to your microcontroller kit, this should work without any issues. Once this is done, it will run some setup, because it has to not only establish a connection, it also has to download the file, the .out file, to your microcontroller kit. And when all that is done, you will see that you now have all these buttons, which means you are ready to go. And as I said, you just have to click on resume, and this is when your code starts running. Alright, and when this code starts running, you should see that flashing LED. So, as I said, this might have been a bit of a long lecture, but it's extremely important that this works, right? So, if necessary, watch this video once or twice. Make sure that you get a flashing LED. Do not continue with the remaining lectures until this is working. It is extremely important, because without this, if you do not have flashing LEDs, there is some problem with your system. It could be an error in your Code Composer Studio. It could be a mistake, something with your hardware kit. It could be that you have not established a connection successfully with your microcontroller kit. It could be any number of reasons, right? So, it's very important that this lecture is successful, that you are able to see exactly the same flashing LED I do. If that's not working, please do post in the Q&A forum. and I will try my best to help you out. I might need some pictures for you to let me know what it is you're seeing instead, because if something is different on your system, by all means post, and then I'll try to help you out. But if this is working, it's good news. We are now ready to continue with the rest of this course. So thank you so much for listening, and see you soon. Goodbye for now.